Hello everyone, let us continue with the Edge 11 frame addressing. Okay, or now we talk about the MAC addresses in Wi-Fi or in Edge 11 standard. Okay, so this is different from our discussion in the previous chapter when we talk about Ethernet. We only have source and destination MAC address or source and destination address. But here in 0.11, we have at least four addresses. Okay, address 1, 2, 3, and 4. Okay, so that they have several how to say several fields in the frame in the IEEE 0.11 frame. Frame control duration, address 1, 2, 3, sequence control, address 4, payload, and so on, and CRC. But we are only going to talk about these four addresses. Okay. Typically, when we use infrastructure mode, we only have these three addresses: address 1, 2, and 3, because address 4 is only used in active mode. Okay. And then if you look at the Wireshark capture, you may have different version of address 1, 2, 3. There is like base station address. There's different namings of address in at 0 to 11 frames. But then in general, if you in summary, um, this is the summary of the address in 0 to 11. Okay, so address 1 is used for the MAC address of wireless host or access point that receive this frame. Or so basically, this is the receiver. So if the receiver is the access point, then this is the access point, the MAC address of the access point. Okay, so the wireless interface. Okay, remember this is the wireless interface of the access point. Okay, so if the receiver is the host, okay, so this will be the MAC address of the host. Okay, again, this is the Wi-Fi interface of the host. Okay, now the address 2 is the transmitter. Okay, so it can be either the wireless host or the access point. If the transmit or if the data is coming from the access point, then this will be the MAC address of the access points. Okay, and if the data is coming from the host, then this will contain the MAC address of the host. Now, the address tree is the MAC address of the router interface to which access point is attached. All right, now we can have in practice we can have access points that are like independently from the routers. So they are not part of the routers. So like the wireless router that we commonly have. But let's say for the buildings, normally they have several access points. They are connected to one controller. So this access point they are not router by itself. Okay, so we can easily divide, or we can easily separate between the MAC address of the access point of the this wireless access point and the router itself. Okay, because the router is somewhere else. Okay, but then if the access point is attached to the router itself, then again this is really the router access, the router's the MAC address of the router interface. Okay, which is connected to the wireless networks. Now let's see the examples. Okay, and for more detailed examples, there is tutorial provided for you that you can see different address 1, 2, and 3 for different scenario. Okay, so now when host 1 is sending a data to access points, okay, through wireless LAN or Edge 11, then we are using the Edge 11 frame. Okay, so now since the receiver is access point, so address 1 will contain the access point MAC address. Okay, and then since the sender is H1, the host 1, then the address 2 contains the H1 MAC address, and the address tree contains this interface of router 1. Okay, so let's say if we have interface number 1 and 2, So this contains the interface number one, MAC address of interface number one and router one. Okay. Okay. Now when the access point forwards this frame to the router, then since it is using the Ethernet or it is using the cable connection, so most probably it is using the Ethernet. So we are using the Ethernet frame or 802.3 Ethernet frame. So now again we are going back to the previous the format that we talked in the previous chapter. So in the MAC destination header is interface one of router one. Okay, and the source address of this frame is the H1 MAC address. Okay, so it's not. Please note that this is not the access points MAC address, but instead it is the H1 MAC address because this is really the source of the packet. Okay, now we talk about the other fields, header fields in the H.11. There is a frame control. Okay, okay, so there are different things in the frame control. We'll talk about it later. And duration is duration of reserved transmission time for CTS and RTS. And there is a sequence control as frame sequence for reliability transfer. So this is it's trying to do the same as the TCP, but again this is not in the TCP level. This is at the link layer level. So there is a sequence control for reliable data transfers. Since we also have the acknowledgement mechanisms. Okay, now the frame control, there are different several types of the packets. First, there's a protocol version, then type of this packet type. Okay, there are various types of the packets. It can be beacon, okay, or maybe data sent that from the host or from the access points, then subtype, and then to AP, and then from AP. Okay, so this is the just indicators whether the packet is coming from AP or to AP, and then more fragments if there's more fragments, and if there's retry for management more data, and WEP. This is for the old encryption technique or authentication, WEP, and this is reserved. Okay. Okay, so from frame type, RTS, CTS, acknowledgement, and data. Okay. All right. Now let's talk a bit about the mobility in 802.11. If we are still within the subnet, then this is easy. Okay, because we can still use. I mean, there is no change in the IP address most probably, so we can still use the same IP address, and so we can use the self-learning just to let this switch to learn to which access point is now the host one is associated with. Okay, so we can use the same mechanism as we talked about in the previous chapter 6. Okay, now let's stop here. Let's continue with the advanced capabilities of the H.11 in the next video. So we'll talk about the rate adaptation, or adaptive modulation and coding, and also about the power saving modes in the H.11. Okay, then see you again in the next video.